Hey everybody, it's Mike with Monkey Fab. Today we're going to learn to control the arc and the heat input into the metal as we're learning to weld. And we're actually going to be welding today with arc shots. Because Mrs. Monkey Fab decided to come in and do some welding so I could record it, and I think it turned out pretty well. I'm pretty happy with the results of it. We're going to be welding on steel, and you know, if you're doing this at home, the drill's good for anybody. I think it's a little tougher with aluminum just for the fact that aluminum has a tendency to heat soak really quickly, which changes all the things you have to do to keep the arc control. So we're going to be doing it on stainless steel, and but you can do it on regular steel. It doesn't really make any difference whatsoever. Just you know, a good thing to do is to go ahead and buy yourself a sheet of 4x8 10 gauge or 11 gauge steel. You should be able to pick that up for about $100. Well, I don't know, with the steel tariffs it might be more nowadays, but you know, a couple months ago it was about $100, and that would give you more practice than you'd ever need to do. You just have to be sure to remove the mill scale off of that. And I made a video for removing mill scale, so you should go check that out if you have carbon steel and want to prep it to weld. But all that scale's got to come off. You have to be down to shiny bright metal. As we talked before, you can only weld metal. You can't weld air, paint, grease, any of that stuff. So we're going to talk real quick about the machine settings. We need to set our machine, if we're going to do stills, to DCEN. Direct current electronegative. So our heat is going into our workpiece and melting it, and we're not going to be doing AC or DCEP, because that would put the heat, it would be the wrong setting for what we need. We have to use DCEN if we're going to weld steel. Amps, if we're going to set amps, the rule of thumb is 1 amp per thousandths of an inch. So let's say if you're welding let's say you're welding 16 gauge. So 16 gauge is 0.065. This is 65 thousandths of an inch. So we'd set our machine for 65 amps. Generally, this is a pretty good rule of thumb. What I'll usually do, and realize this changes. So if you're doing a different type of weld, so on a butt weld this might be perfect. On a fillet weld it might not be enough. On an outside corner joint, maybe it's too much. It just depends on the joint, depends on, you know, what part of the metal you're welding. So that's just, again, they call it a rule of thumb, obviously. So what I'll typically do is I'll bump my amps up higher, and I'll use my foot control. I'll use my foot pedal to control the actual heat input. I just don't slam it all the way down and hold it. Although when you're starting out, it's kind of easier to do, to just put the pedal down and hold it. But anyway, that's how you determine how many amps you're going to weld at. Now there is kind of a point where there are diminishing gains, diminishing returns. So what we're going to be welding much higher today than that, because we're going to be using 3/8 stainless steel plate, which is pretty thick. And that's part of the drill, is changing the amps and seeing what it does. So I think use either use the lanthanated tungstens or use the thoriated tungsten. I use thoriated on all my stills. It's just my personal preference. I'll be using number 16 GLS cup, the same ones I sell on my website, and the post flow will be at about, I think, 11 seconds, 10 seconds, around there, and that's all for the settings. So just no pulse, just straight current. The torch, we already just talked about that. That's how that's going to be set up. So the drill, what we're going to do is we're going to get a plate out, and we're going to select something. I like to use like little, I got these 8 3/2 acorn nuts, and you know, they're a set size. So what you can do is you can look at that size and you can visualize it and say, okay, I'm going to repeat this, and that's a good drill. I also have a bolt, and the bolt is, you know, so long, and what we're going to do is we're going to make circles and lines, and then we're going to try to do is conceptualize that width. So what we'll begin the drill with is we'll just set the machine, we'll put it for 130 amps, and we'll initiate the arc, and we'll watch it grow as the arc. What I generally do, and I think it's pretty good practice, and a lot of people do this, if you're the metal's sensitive, you're not supposed to do it, but if you want to start an arc, scratch it. Take your tungsten and scratch the spot where you want the arc to go to. And generally that'll get you a nice crisp start every time, first time. And it especially goes for aluminum. A lot of times aluminum will kind of glaze over and it'll be real hard to initiate the arc. If you're stomping on the machine that's going and just you hear the high frequency but your arc won't start, that's what's happening. So if you just kind of scratch the surface with your tungsten and then hit it, you're going to notice you're not going to deal with that problem of initiating the arc. But anyway, off on a tangent there. So what we're going to do is we're just going to push the pedal down and we're going to watch that puddle go out to about the same size we have conceptualized in our mind. This is teaching us to have an idea in our mind and bring it to fruition with our foot pedal by how many amps we put into it. When we let off, we're not just going to sidestep the pedal. We're going to slow it down, and we're just going to kind of wiggle the tungsten a little bit. And once we're done, we're going to keep the torch over top of it. And what that's going to do is it's going to train us to keep our hot metal shielded with the argon. That's good practice. So you'll just make these. So let's say we did these on 130 amps. All right. Next, we're going to turn the machine down to like 120. Touch it. Take your gloved hand, obviously, and touch the metal. Feel it. You want to get used to having an idea of how hot metal is and how it acts when it's hot. Now you're at a much lower, not much, but a semi-lower rate. You're going to do the same thing. Just try to make those dots the same size, and what you're going to notice is it might need a little less foot pedal input because it's less amps. Of course, it's also got heat in the metal now, so maybe it's not really all that different. Now you bump it up to 40. It doesn't make a difference. It doesn't really matter. Just change it and do the same thing. Okay? Just keep making these dots, and when you're doing it, feel it in your foot. How far do I have to go down? How long does it take? And that's going to again help you get an idea of what happens when you crack that throttle, crack the pedal on your machine and it starts an arc. This is good practice. Okay, the next thing we'll do is we're going to do the same thing. We're just going to keep changing this, but we're going to make lines. We're going to make consistently wide lines. And the cool thing about this is now we're involving the travel speed. So you might notice that you can mat 130, just go all the way down, and you have to go real fast to keep the bead the same width. Or you can kind of control it with your foot pedal and move your hand the same. But your travel speed can stay consistent, but you're changing your foot pedal. It's all interrelated. And what that's also doing, again, is it's making you focus on what the ideal arc should be and conceptualize that in your mind and then bring it to fruition in your mechanics of your body, what you're doing with your machine, how you're moving. And this is basically the drill. So that's it. And those are the things it's going to teach you. It might seem dumb, but it's not dumb. It's a really good drill, and it pays dividends in the future on stuff we're going to be working with. So this is what I want you guys to focus on today. And I had this all on video, so we're going to do it now. I appreciate you guys listening to me talk real quick. I want to throw my new Monkey Fab Garage. I've been doing this series, and I thought to myself, man, somebody should throw together a kit so someone can just buy a kit and have everything they need in one place. And being a retail guy, I said, well, why can't I do that? So I put together a TIG starter package. There's different variants of it, but basically you can just go in and you get everything you need in a package at a very affordable rate, and the shipping's all combined, so you save on the shipping as well, as opposed to trying to piecemeal a kit together. You get everything you need. So if you have your basic air-cooled large torch, you get the you can get a stubby gas lens. You can get one of the GLS Fab cups. You get every filler that I primarily use 99% of the time, and it ships for 20 bucks to you, unless you are. No, I think we even managed to cover Puerto Rico and Hawaii and Alaska, so that's cool too. Because I've been to all those places minus Puerto Rico, been stationed there, and I always felt like I was getting burnt when I had to pay like 60 bucks to get stuff shipped. So I hope you guys appreciate that. And without further ado, we're going to get started on the video. Recording. So this is what I was talking about by comfortable is, you know, you got a good table. This is Mrs. Hennessy. This is Miss Monkey Fab. She's going to be doing the welding today, and I'm going to be doing the filming. So we're well planted. We got a solid ground on the metal table. I got this fancy little copper plate to weld on that is a really good conductor of electricity, and this is good. Also, what we'll do, and what will probably help you, is what I usually do is you have to be studious and keep your tungsten separated if you use two like I do, but I have my thoriated, I just have a pile of them on my table, and I'll sharpen both sides of them, so if I kind of goof up one, I can just flip it over and keep on trucking, and it also gives me a lot of time focused on whatever it is I'm doing, which is usually work. And even if you don't touch the tip, sometimes just stuff will kind of float up to it. I'm not sure if that's electricity and the weld pulling it or what, but it'll get stuck on there, and you'll have to clean them up anyway. It just gets ucky. You gotta clean them up. That being said, if you get a big old goober on the end of this thing, don't take it out. Take it out your tail of your torch, stick it in and lock it down, because then if you get a goober on the other side, now your gas lens and everything is stuck in the middle of that thing. So you have to actually cut it. You have to break off one end or cut it. And so don't, if it does get gooped up on one side, just put it down and just grab another piece of tungsten and move on. So we're going to go ahead and set the machine up. We're using 304 L 3/8 plate today, just because I have some laying around. And we're going to turn the machine on to so it's on 135, and that's good for the thickness we're using. 120 would be good too, even if they were on that. But we're learning arc control, so it doesn't really matter. We just need enough or more than what we need to melt the metal and break it apart. And our gas is flowing 25 CFH. We got the number 16 cup in the torch, on the torch, the GLS Fab 16 cup that I saw on the website, and we're going with thorium tungsten with about 3/4 of an inch, maybe 5/8 of an inch stick out. Good, baby. And what you want to notice is how she's keeping the torch steady at a nice height. It's about, like I said, 3/30 seconds off the table, and then she'll just watch the puddle until it gets to be about the right size that she wants. Okay, can you make another one?
Same size?
Yeah, about the same size. What we'll do is we'll turn the machine down. So we were at 135
So we're going to go to 120, and we're going to see so you have to go just a little bit longer maybe.
Okay.
And what you'll also notice is that she is keeping the torch in the same spot until the post flow. Until the post flow finishes. And you'll also notice when she comes off the power, she's not just abruptly ending the arc, she's trailing off on the arc. So she's starting and she's, whoops, sorry, and then it trails off and stops. It's brilliant. Good job. Okay, so again, initiate the arc, give it the gas, watch the puddle start, there you go, and it gets about as big as you need it, and then trail off, and in the arc, and keep the shielding gas over top of it until the post flow finishes. Now we're using, like I said, 3 Now we're using a pretty big chunk of metal. It's a 3/8 stainless steel piece of plate here. And it has a lot of ability to cool itself. So one thing I want you to do is fill the plate with your hands, with your gloved hand obviously. Can you do that?
What?
Can you put your hand on the plate and fill it with the glove? How's that feel?
A bit warm.
A bit warm, yeah.
Not much.
Yeah, because it has a tendency to be able to soak up a lot of heat being that thick. And that's one thing you want to keep in mind when you're welding is... Alright, so the wife has done some practice dots, and the goal was to use this as kind of a guide. So what we want to do is these guys, but this is hot, basically want to be about the same size as nut, and you'll see it stays pretty consistent. This row was done at 135 and this was done at 120, I believe, or 125. I said on the thing.
120.
You'll see these guys maybe just a little bit smaller, so just maybe staying a little bit longer. And I'm not going to fault my wife at that because I am talking the whole time she's trying to work, which must be very distracting. And that's okay, because the point is to show you guys what we're doing and why we're doing it. So next what we're going to do is we're just going to make some lines, and like I said, I like to have like a guide of what to visually reference. So we're going to reference this screw here, and we're just going to try to make a line about roughly the same width and length as this. This is good in the fact that it'll help you not just with the controlling your arc, you know, your heat input and your travel speed. This is also good because it helps you conceptualize in your mind what you want to do, what carrying the same width bead, a consistent bead through your weld is like in your head, and that's important if you want to make, have good looking welds. So anyway, our next step is we're going to just make some lines. So we're going to shoot for that, and we'll get that. The amperage or the frequency? I think you're talking about amperage, baby. Mm-hmm. Where do you want me to put your amperage at? We're at 120 now.
What high? Up.
You want higher? 135?
Mm-hmm.
Okay.
It's different, yeah.
We'll go 135, okay?
Mm-hmm.
Alright, so now we're going to shoot for a line roughly the same size as the screw there. And what you're going to see is, you're going to see the travel speed maintained, and you're going to see the width trying to be maintained. So that's kind of the goal of this exercise here. is we're going to put the pedal down and try to maintain the right width across the line. So whenever you flip, oh, let me start your machine on, huh? Keep the cooler on first. And there are our lines, and they look pretty good. I think we went a little bit wider than what we were aiming at, but not much, which is fine. The most important thing is you're consistent with your own lines. So especially once you get one line down, then it's easier to copy it in your mind and repeat. So we're going to spin this guy around, and we're going to do a few lines on the other side. Okay. You'll see she's resting the tungsten on the bead. That's an easy way to keep yourself covering the weld when you're finishing, is just give it a second to cool, and then you can kind of just set the tungsten right down on it, and that'll, kind of help keep it shielded.
One more?
Yep, keep going. Okay, and these were done at 120 amps. And next, I'm going to turn the machine down all the way to 100. You should see is my wife slow her travel speed down. Because you got to go a little bit slower now to maintain that same width in the bead. Great. Okay, do one more at the very, just one more. Seemed like your hand wasn't very steady that time. What happened? Were you not comfortable? Yeah. You're getting too close to yourself?
Yeah.
And your arm wasn't able to rest on the thing, so.
Sorry.
Why?
Last one.
No. I wanted to record myself saying that so
Oh.
people could hear why your hand got shaky. They know, because it's important. Like, if you're doing this the first time, you don't think about all that stuff. So when you got someone to watch you who can say like, "Hey, I saw this or that," then it hopefully help other people, right?
Mm-hmm. Okay.
That's why I pointed it out, not because I was trying to be rude.
Oh, no.
You know I wouldn't do that, baby.
No, I know that.
Okay. So so that's the drill in how to control your arc. how the amps, so teach yourself how the amps and how your foot and how your travel speed affects the metal that you're welding on. You can go ahead and you can do this with anything. Carbon steel is really good to start with. You can get on eBay and get like 4x4, 8-inch plates of 1/8 carbon steel, really cheap. You can get a whole 4x8 sheet of carbon steel for probably about $100 if you look around where you're at. And it's, if you got a plasma cutter or something, a speedy grinder, a zip cutter to, cut yourselves out some coupons, a 4x8 sheet of carbon steel, well, you could weld that up. By the time you're done, you'd be pretty doggone good at welding. So we want to thank our wife, thank the wife, Sassatorn, for joining us and being so kind as to run some beads for your viewing pleasure, and allows me to record it and also you to see a clear, detailed photo of what's video of what's going on. So I hope that will help you guys out. What would help me out is if y'all would drop by my website at monkeyfabgarage.com and check out my new TIG starter kits. Thanks for dropping by and checking out the videos. Mike from Monkey Fab signing out.